Hi there, I'm Leah Applegarth, and we are going to talk about the fundamental theorem of algebra. Our learning objective is to use the fundamental theorem of algebra to solve polynomial equations with complex solution. Our essential understanding, you do not have to write this down, is that the degree of a polynomial equation tells you how many roots the equation has. For example, so here's a parabola. When you have a parabola with a vertex below the x-axis with a positive coefficient, you end up with two real roots. When your parabola has a vertex that is on the x-axis, you have one real zero. And when you have a positive coefficient and your parabola is above the x-axis, you have no real zeros. So the fundamental theorem of algebra, write this down, says if p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n roots. So the roots and the degree are the same. Fifth degree, 5 roots, including multiple and complex roots. A degree of 3 means 3 roots. So what this means to you is when we are solving a polynomial equation, we want to find as many roots as the highest degree. Okay, so the first step is to put the polynomial in standard form. So I'm going to move each over to the left-hand side. So I have everything on the left and 0 on the right. I'm going to go fourth power, third power, second power, and x. So fourth plus 2x cubed minus 13x squared plus 10x equals 0. And then I'm going to find the possible rational roots. I can factor out an x from this, and it's x cubed plus 2x squared minus 13x plus 10. So I know x equals 0 is a factor, and now I've got to find another root for x cubed plus 2x squared minus 13x plus 10. So I'm going to go ahead and graph this on Desmos and find the roots. Alrighty, so when I graph these on Desmos, I see that my roots are -5, 1, and this guy over here is 2. So I don't even have to use synthetic division to factor it out. I have 4 linear factors. I have 0, -5, 1, and 2. So then I can go ahead and write my roots. The roots are -5, 1, and 2. And there's 4 of them. So by the fundamental theorem of algebra, these are the only roots that I can have. I can't have any others since I'm power 4. If I want to, so I'm going to write this as a factor. So instead of x to the 4th plus 2x cubed minus 13x squared plus 10x, I can write that as x times x plus 5 times x minus 1 times x minus 2 equals 0. And then x equals 1, -5, 1, and 2 are the roots. Okay, so when finding all the zeros of polynomial functions, so we're going to do that same process again what are all the zeros of our function g of x equals 2x to the fourth minus 3x squared minus x minus 6. So we're going to find our real roots first. So when we put this into Desmos, we find that our real zeros are at x equals negative 1 and x equals 2. So we're going to go ahead and, so let's write this, let's mark those down. So our real zeros are at x equals negative 1 and 2. So what we're going to do is factor out those factors. So we're going to divide our polynomial function by our first linear factor. So this, as our linear factor, we use the root theorem to remind ourselves that the linear factor for this is x plus 1. So I'm going to use synthetic division. So I'm going to put my root here. And then it's 2, negative 3, 0, because I don't have an x squared term, so that gets to be 0, negative 1, and negative 6. For synthetic division, I bring down the first one. Negative 1 times 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 1 times 5 is 5. 5 plus 0 is 5. Negative 1 times 5 is negative 5. Negative 1 minus 5 is negative 6. And negative 1 times negative 6 is positive 6, giving a remainder of 0. So our new function, when we divide out x plus 1, is 2x cubed minus 5x squared plus 5x minus 6. Now, we know another linear factor. We know x minus 2 is another linear factor. So we're going to do synthetic division again. So we go 2 is our root. We have 2, negative 5, 5, and negative 6. So the first thing I'm going to do is drop down that 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. 5 plus negative 2 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. So the last one I have, so I've factored out an x plus 1. I factored out an x minus 2, and we're left with 2x squared minus x plus 3. So now we're here on step 3. We're going to use a quadratic formula to factor the very last pieces of our polynomial function. So when we got the negative b plus or minus b squared minus 4ac over 2a. So b is negative 1, so it's negative 1 plus or minus square root b squared, so negative 1 squared, minus 4 times a, which is 2, times c, which is 3, all divided by 2a. Okay, so now my job is just to simplify, simplify, simplify. Negative and negative give you positive. Plus or minus stays the same. Square root stays the same. 1 squared is 1. Minus 4 times 2 is 8. Times 3 is 24. All divided by 4. So this is 1 plus or minus square root of negative 23 divided by 4. But we know that the square root of a negative number is I. So this is 1 plus or minus I root 23 divided by 4. So when we have to write out what are all the zeros of our function. So we've got -1 and 2. And remember, this is a 4th degree polynomial, so the most I can have is 4. We got 1 plus I root 23 over 4, and 1 minus I root 23 over 4. 4 zeros. Okay. So in summary, every polynomial equation has of degree greater than or equal to 1 has exactly n amount of roots, including multiple and complex root. Every polynomial of degree n greater than or equal to 1 has n linear factors. And every polynomial function of degree n greater than or equal to 1 has at least one complex 0. All right, you guys can go ahead and write your summaries. Make sure to include your learning objectives and any key points we mentioned in this video. Have a great day.